Good morning. Can you hear me?
Yes.
Okay, so we start today's lesson. That is about equations of higher degrees. Okay, so if I want to give it a title, I would say let me be more explicit. Polynomial equations of degree higher than 2. Yes. So that is the topic of today's lesson. Of course, the reason that we are interested in talking about polynomial equations of degree higher than 2 is clear because we already know how to solve a degree 1 equation. For example, if I give you 2x minus 4 equals to 0, you know how to solve it. That's its first degree equation. And then if I give you, for example, x squared plus 5x plus 6 equals to 0, you still know how to solve it. This is a quadratic equation of degree 2. But if it becomes a higher than 2, then of course this problem is not trivial at all. Okay, and then I want to just exactly go around what you need to learn in this course, but to motivate you, for example, so the main strategy in tackling these kinds of problems would be factorization of the polynomial given to you, which in principle is not a trivial thing to do. It's not that easy, but you don't need to be worried about. Most of the time you will get a hint how to factorize that. We want to talk about these ideas today. Okay, so let me start with a motivating example. Okay, so let me write example. Solve the following equations. Okay, so let me start with a very simple example first. Number 1, if I ask you to solve x to the 3 plus 5x to the 2 plus 6x equals to 0. Okay, so how do you solve this equation? So in principle, this is an equation for today's lesson. Yes, it's a polynomial on the left hand side equals to 0. And if I ask you what is the degree of this polynomial, you say that the degree is the highest exponent appears for x here, and that is 3, which is more than 2. Yes, so in principle, this is one of those equations that I was talking about. But this is very, very simple. The reason that this is very simple, because factoring this polynomial is very simple. So if you want to solve this equation, you would do it something like that. So what you do, you first factor an x out, then it becomes x squared plus 5x plus 6 equals to 0. Then now you say that this number multiplied by this number is supposed to be equal to 0. So by the zero product rule, immediately becomes clear that either the first one is equal to 0, so you are done, this is your answer, or the other one is equal to 0. Yes, x squared plus 5x plus 6 equals to 0. So it means that we were able to reduce this third degree polynomial equation to a first degree polynomial equation, which was so trivial that we just got the answer immediately, and a second degree polynomial equation, which in principle we know how to solve it. So you see, the base is factoring this polynomial, and of course another key point is that the right hand side is equal to 0. If the right hand side turns out to be 1, this would be a dead end for this strategy, because we cannot say that I have the product of two numbers is equal to 1. I cannot draw any general conclusion out of it. Yes, so this is extremely important to realize that first of all we need to factor the polynomial. Secondly, the right hand side has to be 0 and nothing else. In that case, we can use this method to solve the problem at least easier. Yes, even if I have a fifth degree polynomial, when I factor it out, the involved polynomials have lower degrees, definitely. And then, of course, in principle, solving a polynomial equation with a lower degree is much actually simpler. The reason actually we are interested in this topic, because unfortunately, there is no formula, there is no closed formula that you can use it and solve and find the roots of any polynomial equation. For example, for first degree we really don't need any formula, but if you want, we have it. Equals to 0, x becomes minus b over a, so that I would consider the formula that solves all first degree polynomial equations. But then if I have the quadratic polynomial, all of you know either ABC formula or PQ formula, so you have a formula. For the third degree and the fourth degree, we have formulas, but the formulas are a little bit horrible, but anyway, we have it. But for degree 5 onwards, we do not have any formula. And the problem is that this is not our weakness that we don't have the formula. Norwegian mathematician Abel actually showed that this is impossible to have a full formula that gives you the roots of generic polynomial equations of degree 5 and higher. So that is the problem. So this is not the problem that we cannot find it. Abel showed that it is not possible to find such a formula. Okay, so this is why I want you to understand that solving equations, polynomial equations, is actually a difficult and important task. I say important because there are a lot of applications in science and engineering for that. Usually you have to solve a polynomial equations in some of the practical problems. But then, on the other hand, we don't have any general formula for that. So this is why studying how to solve these polynomial equations are important. Today in this Math 4 lesson, we just study a very simple idea of that. The idea is that if possible, factor it out. Of course, this is a very general strategy, and this is an ambitious goal actually, because factoring polynomials would be the final solution if we can factorize the polynomial. And the other method is that sometimes we don't know how to factor the polynomial in the first place, but if I can extract some piece of information related to the polynomial, using that piece of information, I can use it with some techniques and tricks that I will teach you today so that you can factor your polynomial. Okay? Okay, so yeah, these are just general ideas. Everything becomes very clear shortly. So, again, let us go back. I give you an equation of this higher degree and I ask you to solve. The first way to think about this, is it possible to factor the polynomial? If factoring the polynomial is easy, that is your solution. Factor it out and use the zero product rule on the condition that on the right hand side you have 0, and then in principle you should be able to solve that. So I would solve this problem x squared plus 5x plus 6. You can use PQ or ABC formula, but if you don't mind, let me just always use the ABC formula. So it becomes minus 5 plus or minus b squared minus 4ac becomes 1. Square root of 1 is 1 divided by 2 times a. So I will get two more answers. One of them is minus 3, or the other one is minus 2. So you see that this problem was not a probably Math 4 problem. Yes, in principle you should be able to solve this even in Math 2C. Okay, but let me give you an example that the things are not that trivial. For example, let us assume that I am giving you this equation, x to the 3 minus 7x plus 6 equals to 0. Okay, so you see, even though that's not a complicated polynomial at all, it's actually very simple, but the point is that factoring it is not that trivial. I give you two examples to show that factoring polynomials could be actually extremely hard sometimes. So in this example number 2 and number 3 that I am giving to you today, so don't be worried about how should I know these things. I just want you to be exposed to this material so that you understand what is the nature of difficulty there. I don't know, do you have any idea how to factor this polynomial? I just want to see how do you act. The method is a little bit strange. But do you have any idea beforehand? Okay, so let me solve this problem. So you just try to follow me. Don't worry about how should I know this method. I need to develop this method. You just try to understand the problem. So I would say that my equation is this. Let me just forget about the equation and just concentrate on my polynomial. If I want to factor it out, instead of minus 7x, I would write minus x minus 6x. And then I will write plus 6. So you might say that why I should think to break minus 7x to minus x minus 6x. First of all, I want you to understand this is a valid way of breaking things, yes, because minus x minus 6x becomes exactly minus 7x, and I haven't changed anything at all. So this means that this equality is valid. But of course, you might say, why didn't you choose minus 3x minus 4x? Minus 3x minus 4x is also minus 7x. You might say that why you haven't chosen, I don't know, 10x minus 17x. 10x minus 17x is also minus 7x. The answer is that this is the only way that we can break out and be able to solve the problem. How do I know that? By some experience. But if you make the problem complicated, even I don't know how to break the terms out. So that's exactly the hard part of this factoring polynomials. It could be quite hard if I want to understand how can I factorize, break out the terms so that I can factorize it. You might say, okay, let us see how this will work. I will take this one with that one now, and I will take these two together. So from the first pair, I factor an x out, then x squared minus 1 is left. And from the second pair, I factor a minus 6 out. It becomes x minus 1. Okay, but this seems to be useless unless you realize that this one on its own is a conjugate pattern, so I can factor it even more. So it becomes x minus 1, x plus 1, and then I will have minus 6x minus 1. Yes? And now you realize why this was good, because x minus 1, after all these calculations, appear as a common factor between the whole expression, so I can factor it out. And then what is left from the first term is just x and x plus 1. What is left from the second one is minus 6. And then what happens? So it becomes x minus 1, and this becomes x squared plus x minus 6. And then, so you see that I wrote it as a factor polynomial. Factored means that it is written as a product. So this expression was a third degree polynomial. By this very strange technique, I agree that this is not trivial at all. So we were able to factor it into two polynomials, x minus 1 times x squared plus x minus 6. So in principle, my problem is solved. If you want to, of course, you can continue and factor this out, which is not my goal to teach you. You already probably know how to factor it out, but my point is that a third degree polynomial was broken out into two polynomials, yes? X minus 1, x squared plus x minus 1, minus 6. And now the zero product rule comes to my help, yes? So therefore, I would say that x to the 3 minus 6x plus minus 7x plus 6 equals to 0 implies that instead of the left hand side, I put its factored form equals to 0. Then you conclude, because of the zero product rule, either the first one is 0 or the second one is 0. If the first one is 0, you get your answer immediately, so this x equals to 1. And the other one is a quadratic equation, so For example, if you want to use ABC formula, or you can factor it out, as I said, it's easier probably here. So this becomes 5 divided by 2, and then there are two other answers, so minus 3 and the other one, x equals to 2. Yes? So you see that I was able to solve this equation. But of course, the very tricky part is breaking this term into more appropriate terms, which is not trivial at all. But if you can factor it out, at least the take-home lesson from this is that if I can factor a polynomial into polynomials of lower degree, my chances of solving the equation increases. Yes? Any questions so far? But don't worry about this one. This is something that's understandable when you see the solution, and that is enough for my purpose right now. No questions? Okay. So let me give you another one which is also even more harder than this one. So let me write number 3. Again, the same idea. So we want to solve this equation. X to the 3 plus 6x squared plus 11x plus 6 equals to 0. Okay? So even this is even harder. So if I want to solve this, of course I myself did some trial and error. And by the way, writing these are not hard, because I can just write some polynomials for myself and multiply them and give you the answer and ask you to factor it out. It is very hard. Okay, so if I want to factor it out, the method that I realize is that I want to break out this term and this term. How? Very particular numbers. If you don't find the correct numbers, this will not work. Instead of 6x squared, I write x squared plus 5x squared, even though there are infinitely many choices to make 6x squared as the sum of two terms, but this one is the only one which works. So the other one, instead of 11x, I write 5x plus 6x. Again, there are infinitely many ways to break this into two terms, so this is probably the only one that works. And then I have a 6 here. So what I have done, instead of 6x squared, I have written this, which is valid. Instead of 11x, I have written this, which is also valid. But why this is good, but hopefully you'll realize why this is good, yes? I can, for example, take this one with that one. I can take these two. I can take these two. Okay, so what happens? I can factor an x squared out. It becomes x plus 1 between the first pair. Between the second pair, I factor a 5x out, so x plus 1 is left. And between the last pair, I factor a 6 out. So now you realize that this method is successful because it generated a common factor which is common to all the terms. And definitely I can factor it out, and what is left for me is x squared plus 5x plus 6. Okay? So you see, that was the highly non-trivial part of the solution. If you want to start everything without any extra pieces of information, which is of course not the topic of your lesson. Okay, but I want you to understand where the hard part is lurking for us. That factorization. But then I can immediately start solving the equation. Yes, x to the 3, 6x squared plus 11x plus 6 equals to 0. This would imply that x plus 1 multiplied by x squared plus 5x plus 6 is equal to 0. So this then would imply that because of the zero product rule, either the first one is 0 or the second one is 0. And these are simple. So the solution to the first one is x equals to minus 1. And the other one is x equals to minus 2. This is so simple, let us not spend time on solving it, yes? And the other one is x minus 3. Okay. So you see that what is going to happen in principle. But now, I assume that someone tells you one of the roots, or for some reason, from some part of the problem, you yourself somehow are able to find one of the roots. Then you don't need to be creative at all. So let us solve the same problems, the second one and the third one. Assume that someone provides us with an extra piece of information. So this is the lesson that you need to learn very good. Okay. So example. So this is the type of problem you will face. So instead of asking you to solve this equation, I will say something like this. I would say that consider the equation x to the power of 3 minus 7x plus 6 equals to 0. Usually these problems have two parts. Okay, so 1 and 2. Actually the first part, even though brings you some points for the exam, but this is just a hint for the second part, and it's a very valuable hint. Okay, so for example, we know how is the situation. We already completely solved the problem and we got 3 answers. So let us say that for some reason they know about x equals to 1, and say that show that x equals to 1 is a solution to this equation. Okay, so you see, this is given, this equation is given to you. Someone tells you that check manually by hand that x equals to 1 is actually a solution to this equation, and then number 2, solve the equation. By solving means finding all possible roots. Solve the equation. Okay, so the first part is very simple. Okay, so part 1, what you need to do, you need to replace x with the proposed number to see that if this equality is true or false. Well, of course you have to show this is true. So I would say the left hand side is equal to, instead of x I put 1, it becomes 1 to the 3 minus 7 times 1 plus 6. If I calculate that, it becomes minus 7 plus 6, which is indeed 0, and is equal to the right hand side. So therefore x equals to 1 is a root. So I don't know why I didn't change my color. Hopefully I can do something here. Okay, so number 2. I will consider 2 methods. The reason that I'm considering 2 methods, because both of them are given in the book, even though I will never myself use the first method, but I want you to at least know and understand that. So I would say method 1, undetermined coefficients. I myself prefer not to use this one. I don't know. The second method, the method of long division, is more standard. So let me just concentrate here and see what is the meaning of undetermined coefficients. So if I don't know anything about this equation, as I showed you, solving this equation might be hard. But now that someone gives you one of the roots, you know that when I factor this one, so when I factor this expression, I have something to know about factorized form of this polynomial. Why? Because I know that x equals to 1 is and a solution by inspection. Yes, I checked by inspection that x equals to 1 is a solution. And on the other hand, I know that if I am able to factorize this should be factorized to 2 or more polynomials equals to 0. But one of them equals to 0. One of them equals to 0 should give me this answer. So hopefully you realize that at least one of these factors that appear in the factorized form of this should be x minus 1. And so make sure that this is understandable. If not, please ask me. What I'm saying is that if x equals to 1 is a solution, definitely x minus 1 is a factor which, using the zero product rule, will give rise to x equals to 1 as one of the solutions. Is there some of you doesn't understand this? Okay, so this means that if you understand that, it means that I don't need to start just from scratch. I know something about this. I know that when I factor it out, this should be of this form: x minus 1 multiplied by another polynomial, which I don't know yet. But this is clear that the total degree on the left hand side is 3. If I want to write this equality, what I write on the right hand side should also be of degree 3. But this is degree 1, so it means that what is left for me here is a degree 2 equation. Is a degree 2 polynomial. Okay, so the degree 2 polynomial in general, I don't know which one is that, but it doesn't matter. Any degree 2 polynomial would be of this form. So this is the crucial part. Yeah, if you don't understand how I wrote this, please let me know so that I can explain it more. Okay, and the reason this method is called the method of undetermined coefficients, because these coefficients are yet undetermined. I'm supposed to determine them. But it is not hard, because I can spend some time to multiply this out and equate it with the left hand side and read the coefficients by this equality. It doesn't matter if you start with A, B, and C, but even without starting, you already can immediately guess what A is. Yes? Okay. So let us assume that we cannot guess. Let me multiply them. Of course, life would be a little bit harder for us, but it works. So yeah, I multiply the right hand side. So this becomes ax cubed plus bx squared plus cx minus ax squared minus bx minus c. I write it as a standard, a third degree polynomial. A standard means that I should have 1x cubed, so which I already have. I should also have 1x squared, but I have x squared in 2 places, so I factor x squared out to make it 1, to make x squared appear in 1 place. And then you see that I have 2 places where x appears, so I will factor x out, so make it like this, and then you see that this is equal to. So this is the right hand side. But I want to fine-tune A, B, and C in a way that the right hand side becomes identically equal to the left hand side. So then this would imply that the coefficients should correspondingly match. So it means that the coefficient of the third degree term, which is A, should match with the coefficient of the third degree term on the left. So this means that A should be equal to 1, which was not easy to guess from the beginning. And now, what is B minus A? Now, can you tell me what is B minus A? And what is C minus B? And what is minus C? So what is B minus A? Yeah, it is 0. Why? Because the B minus A is the coefficient for the second degree term, but there are no second degree terms here. So it means that the coefficient should be 0. And what is c minus b? C minus b is the coefficient of the first degree term, so this should be minus 7. And if I ask you what is minus c is the constant term, 6. And then this is 4 equations, but in 3 unknowns. So if you want to see if this is going to work or not, you need to be patient and find all of them and check all the 4. Okay, not just 3 of them. Okay, but from the first one, of course, a is equal to 1. Okay, and from here, b is equal to a. So this means that b should also be equal to 1. And then from here, c minus 1 is equal to minus 7, which gives a rise to c equals to minus 6. But you need to be careful. You need to also check the other one, because if they are not the same, then it means that there are no solutions. So you have inconsistencies, yes? So then it means that it cannot be factorized in this form. But of course, this is not possible because we already checked that x equals to 1 is a solution, so it means that there should be a factor, so what is left for the second one is a second degree polynomial. So you will not actually face a contradiction here, but anyway, so these are my 3 answers. And now what you do, you put them back here. Okay, so it means that now you have the factorized form of your polynomial. But you see that I am not saying that this is not lengthy, but this is not hard. It means that if you systematically know what you're doing, you immediately come up with the answer. A is equal to 1, so instead of A I put 1, instead of B I put 1, instead of C I put minus 6. So this becomes x squared plus x minus 6. And then I realize that this is the factorized form, and of course the continuation on the problem, so you continue, okay? Continue yourself. By continue yourself, it means that I was supposed to solve this equation, yes, so it means that I put this equal to 0, and then by 0 product rule, either the first one is 0, which is of course not surprising, it will give you the same answer, which was trivial from the beginning, which was obvious for us, it was given to us actually, and the second one equals to 0. If I go to the previous page, let us check that if that's true. So you see, I got the same answer, but here you have to be creative, and it is not easy at all. If the problem especially becomes of higher degrees and more terms involved, I would say that for human being, of course there are algorithms, computers can factorize this, but that's an algorithmic way, so they start repeating a process over and over again so that they can factorize polynomials. But for us, it's actually not easy to factorize the polynomials so easy. So you see that here I have to be creative, but of course I didn't know anything about the polynomial. I took the same problem here. I gave you an extra piece of information. Using that extra piece of information, you were able to solve the problem, even though it might be still lengthy, but no problems. You were able to factorize it without being so much creative. Okay, so it means that, and this problem is not considered to be hard in mathematics if it is done systematically. Even though that's a good method, but I myself prefer to work with the second method all the time, and that's called the method of long division. And I want to teach you that method because that's an algorithm that we want to come up with, and using that algorithm we want to factorize this polynomial. So let me write number 2, and then for the rest of the questions, even though you can solve always using the undetermined coefficients, I myself prefer to work with a long division method. So number 2, method 2, okay, so how should we do that? So there are different versions, American version, and I think in your book Swedish version is a little bit different in notation, but everything is the same. So what you need to do, again, the first part is the same. You just do the same thing and confirm that x equals to 1 is your solution. For the second part, you realize that x minus 1, using the first part, you realize x minus 1 is a factor of one of these expressions, yes? If I, for example, if you consider 6 and I give you 2 is a factor of 6, if I ask you what is the other factor, what you can do, you can divide 6 by 2 and you get 3, and you would say 3 is the second factor. So the same idea is here. From this, the first piece of information, from this piece of information you realize x minus 1 is a factor, and not a way to say what is the second factor is to divide this polynomial by this factor, which you don't know so far. You know how to add polynomials, subtract them, multiply polynomials, but probably this is the first time you are supposed to learn how to divide a polynomial by another polynomial. Okay? And that is called the method of long division. So what you do, you will take your original polynomial and write it here. For example, x to the 3 minus 7x plus 6. And then according to Swedish books, you put a horizontal line on top of that. I don't know, another vertical line here and a little bit smaller horizontal line here. Okay, so the original polynomial should be written here. And then what you need to put here is what you were able to guess as the factor based on the first piece of information, the piece of information given in the first part of the problem. It was x minus 1. Okay? And then I want to teach you how to divide this by that. It's an algorithm, so you need to follow the algorithm. Okay, so what you do, for example, you can open up a scratch paper here. So what you do, you only take the first term and the first term and divide this by that. So it's very easy because the first term is just a monomial and you divide it by the first term. If I ask you what's the answer, you would say this is x squared. X squared, you write it here on top. And then what you do, you multiply x squared by the whole expression and write them here, but when you want to transfer the terms here, you change the sign of each term. So what I mean, I multiply x squared by x, it becomes positive x cubed or x cubed. When I want to write it x cubed here, I put a negative sign here, so it becomes negative x cubed. And I do the same thing for the next term. I multiply this by minus 1. Yes, it becomes negative x squared, but when I want to write it here, I would write positive x squared. Okay? And then what you do, you add these two polynomials together. So you add these two, and they are gone. Yes, this one and that one are gone. And then of course this one and that one and that one are left. If I want to add them, they are not similar, so I need to bring all of them down. But it is extremely important to bring the one with higher power, so you need to keep the order from the highest exponent of x to the lowest one. So I am not allowed to write minus 7x plus x squared plus 6. I have to write x squared minus 7x plus 6. Actually, that's it. You repeat this process over and over again so that nothing is left. Okay? And definitely you will reach to nothing is left because you already confirm that x minus 1 is a root. X equals to 1 is a root. It means that x minus 1 is indeed a factor. Okay? Okay, so let me repeat the process. Again, you go to a scratch paper, for example. Of course, this is super simple. You can just do it in your head. Exactly. Take the first one and the first one, divide them. So x squared divided by x, the answer would be x. So you need to write x with its sign here. It is positive x. And then repeat the process. You multiply x by minus 1 and transfer the answer here, but you need to change the sign. So x times x is x squared, you write minus x squared. X times minus 1 is minus x, you write positive x. And then you just do the same process. This time, this one and that one are gone, but you immediately see that these two are similar, so I can add them. Minus 7 plus 1 is minus 6x, minus 6x, and then I will have plus 6. Still it is not 0, so I have to follow the process once more. So again, for example, in scratch paper, the first term is minus 6. You see, the first term here is minus 6, the first term here is x, and then I divide them by x, so it becomes minus 6. Minus 6 is the number that you have to put there. And then you multiply minus 6 here, it becomes minus 6x, but when you want to transfer it here, you change the sign. Minus 6 times minus 1 is positive 6. Positive 6, when you want to transfer it here, you change the sign. And now you see that when I add them, actually nothing is left, because this one and that one are gone, this one and that one are gone, so as we predicted, this is 0. And there are some words that you need to know about these. This polynomial here is called the dividend. This polynomial here is the divisor. This one here, which of course in your lesson it's always 0, so that's the remainder. And this one here is the quotient. And now you realize, I think, what's happening. What you get here is your second factor. Okay? So then it means that by looking at this situation, you realize that what you have written here is equal to this one multiplied by that one. Yes? Of course, this method is not useful. You might say that why we should divide by a factor. Why, for example, I shouldn't divide by x minus 10. If you divide by x minus 10, everything will work, but the problem is that you will not get a 0 remainder. And if you do not get a 0 remainder, you will be in trouble, yes, because x to the power of 3 minus 7x plus 6 would be x minus 10 multiplied by some polynomial quotient, let us call it q of x, and then plus a remainder. Because of this remainder, which is not equal to 0, you cannot say that I factored this. You see, this method only works if r is indeed equal to 0. If r is not equal to 0, then you have to add that r at the end, but what you get is actually not a factorized form of your polynomial. So this is why it fails. This method is useful if you know a factor and the remainder becomes 0. But if you know that it is systematic, you can just do it like that. Any questions? So I don't want to continue. Again, you can continue yourself, because I told you the only main point is to factor the polynomial. When you have the factorized form, in principle, it should be easy for you. So then here, when I want to write something from using this method, I would say x to the 3 minus 7x plus 6 is x minus 1. X squared plus x minus 6. So I have it in factorized form. Okay, so let me give you another example that is still in front of your eyes. Okay, so let us consider this harder one. Of course, we already know the full answer, but let me give you this equation, and in the first part of the problem, let me provide you with this extra piece of information. Okay, so let me make it easier. Let us make this 1 minus 2. So I would say that another example. So let us go to the other page. Example. So I am giving you the same polynomial, which you already know the answer, but at least we can confirm what we are doing is correct. Consider the equation that was the equation we already checked. Okay, part 1. This is actually a hint for the harder part. Show that x equals to minus 2 is a solution. Number 2, solve the equation. Okay, so we already know that x equals to minus 2 is an answer. But assume that you don't know anything. You realize, I hope that I could motivate you that solving this with any extra piece of information is actually hard. You need to realize how to break out these two so that I can factorize it. This method that I am telling you is not short. It's tedious, you need to be careful to do it, but it is algorithmic way of doing things. So it means in general you really don't need to be smart, you just follow the algorithm. But in the first one you really need to be very smart to be able to find those numbers that you want to break these middle terms into those. Okay, so I think the first one, of course, will also bring you some points, which is of course very easy. So I would say left hand side, I replace a minus x with minus 2. And then I calculate it. Minus 8 plus 24 minus 22 plus 6. So I hope that you can immediately see that the answer is 0, and this is the right hand side. So part 2. So can you tell me from the first one, how should I know what is a factor? So by the first part, can you tell me what is one of the factors of this definitely? May you speak louder, please? X plus 2 is a factor, because when we factor this out, it should be something, one of the factors should be something that when I put it equal to 0, it gives rise to this solution. So it is clear that it should be x plus 2. Okay, so let us use the method of long division. What we have to do, oh, okay, I forgot to write it in. Okay, so what we have to do, we have to use the long division method. Of course, you can also check if you like it, you can use the undetermined coefficient method. So what we have to write, we write our polynomial in its entirety here. By the first part, you already guess a factor. So you write your factor here. So we were able to realize that x plus 2 is a factor. And then what I do, I want to follow the algorithm. So let us just do most of the part in our head. So I will take only the first one and divide it in my head by the first one. It becomes x squared. I put x squared here. But then what I do, I multiply x squared to the whole expression and transfer it here with the opposite signs. So x cubed becomes minus x cubed. X squared times 2 becomes minus 2x squared. And then I add them. Yes? When I add them, this one and that one are gone. This becomes 4x squared. It is extremely important to remember that you need to keep the order of the exponents from the highest one to the lowest one. Okay, and then do the process over and over again so that you get a 0 as the remainder. So 4x squared, the first term, divided by the first term is just 4x, positive 4x. And you multiply it, it becomes, you multiply this by that, it becomes 4x squared, you change the sign. You multiply this by that, it becomes positive 8x, you change the sign. So it becomes minus 4x squared minus 8x. And then what you do, you add them, this one and that one are gone, this one and that one becomes positive 3x plus 6. And then you divide the first term by the first term, it becomes positive 3, and then I multiply, change the sign, and add them. So as expected, the remainder is 0. If the remainder is not 0, it means that either your guess was somehow wrong or you did some mistake in the middle. So you need to go back and check your calculation once more. Okay, so now what you need to do, so you should write something like that. Therefore, x to the 3 plus 6x squared plus 11x plus 6 is equal to x plus 2 multiplied by x squared plus 4x plus 3. So hence, when we say x to the 3 plus 6x squared plus 11x plus 6 equals to 0, this will give rise to this, that this product is 0. And if I ask you what is the answer, of course one of the answers was exactly the same that you were given in the problem. Or you would say that x squared plus 4x plus 3 is equal to 0. And I don't think it is hard for you to realize that one root is minus 1 and the other root is minus 3. So we got these three answers. This one was provided for us. If you go back and see our solution, you see that we were able to get the same answers. But here you see, I hope that you agree with me, it could be extremely hard to guess these intermediate steps. Any questions? So let me give you an example that you can work on it yourself. This is something we haven't done before, so let me just write one example, but unfortunately I've forgotten which number is that. Let me check myself first. Let me write this example and I will wait for you to solve it. Of course, the lesson here is not finished. There are some points that I want to complete, but you can still continue reading the book. I will write on a school soft, but don't consider this lesson to be completed yet. Okay, so consider the equation x cubed minus 6x squared plus 21x minus 26 equals to 0. Part 1, show that x equals to 2 is a solution. Hopefully, so try to think about these things. If I don't give this one to you, factoring this might be quite hard. Okay? Number 2, solve the equation in complex numbers. So it means that if the answers are complex, no worries, they are acceptable. Okay, so I want to pause the video and wait for you to solve this problem. When you are done, please let me know. Okay, so if you don't mind, let me start solving it because I have to drive immediately to school. So after finalizing this lesson. So I think the first one is very simple. You can do it on yourself. So if I put x equal to 2, this becomes 8 minus 24 plus 42 minus 26, which indeed is equal to 0. So you already know how to do the first one, but it is important to write it down in the exam. But based on what we learned from the first one, we immediately realize that x minus 2 is definitely a factor of this polynomial. So if I want to solve the equation, I will go and divide this polynomial by this factor x minus 2, yes? Okay, so I will do it. If you don't understand some part of it, please let me know. So I do it in my head. X to the 3 divided by x, I will get x squared. I multiply it there and change the signs and put them below. So it becomes minus x cubed plus 2x squared. And then I add them. It becomes minus 4x squared plus 21x minus 26. And then I do repeat the process. I divide minus 4x squared by x. It becomes minus 4x. I multiply and change the sign here. Yes. And then I add them. It becomes 13x minus 26. Then I divide. It becomes 13. And I multiply that. It becomes minus 13x positive 26. And then I add them. It becomes 0 as I expected. Therefore, so the way that you write is also important. So you would say, therefore, x to the 3 minus 6x squared plus 21x minus 26 is equal to x minus 2 times x squared minus 4x plus 13. So hence, x to the 3 minus 6x squared plus 21x minus 26 equals to 0 implies that this expression x minus 2 times x squared minus 4x plus 13 is equal to 0. And this will give rise that either the first one is 0, which of course it's not surprising, we already knew the answer, or x squared minus 4x plus 13 is equal to 0. So I have to use ABC formula, for example, to solve this. It becomes minus b, which is 4, plus or minus square root of b squared, which is 16, minus 4 times 1 times 13 is minus 52, divided by 2. And then you know this becomes negative. If I ask you to solve it, by default it means solve it on the set of real numbers. Then you would stop here and say that there are no other solutions. So that's also good to realize. This would be the third degree polynomial. If I do not want to work in complex numbers, two of these are not acceptable because of the negative sign under the square root sign. I will get only one answer. The theorem proven by mathematics genius Gauss is to show, he was able to show that if you have a third, any polynomial, it will have a root in the complex numbers. But if you want to work with real numbers, there is no guarantee that if this is third degree, you have exactly 3 real roots. You see that in that case, you have degree 3, but only one of them is a real number. But if you want to work in complex numbers and consider a little bit technical things, that then you will have exactly 3. Of course, you need to consider multiplicities into account. So forget about those things. But I just want to mention that if I just ask you to solve this, it means that you stop here and you say that this x equals to 2 is one answer. But still you have to do this, even though there is only one answer, because you need to convince me that there is only one answer. So you cannot say because there is only one answer I can just skip this part. No, this is part of the solution. But now I have asked to calculate it in the complex number, so it means that I am emphasizing that you have to continue. It becomes a square root of minus 36 divided by 2, and I don't think you will have any problems with minus square root of minus 36. It becomes plus or minus 6 times I divided by 2. And then let me divide them separately, so it becomes 2 plus or minus 3 i's. So if I ask you what are the solutions, there are 3 solutions. One solution is a real number. Of course, real numbers are also complex numbers, so all of them are acceptable. So this one is the other one, and this one is the other one. But if I ask you to draw the graph of this function, for example using GeoGebra, how many intersection points with the x-axis you would expect? Only one, because only one of them is real. Even though I have 3 roots, but 2 of them are complex numbers, one of them is a real number. So if you go and, for example, using your calculator or GeoGebra, draw the graph of this one, there is only one intersection point between the graph of this function and the x-axis, and this happens at x equals to 2, but none of these roots, you can see them on the coordinate systems. Okay, so I hope that you at least somehow understood what's going on. There are harder problems related to this even in the book, so don't consider this lesson to be finalized. Even though I will write the pages that you need to study, you can study on your own, try to solve the problem.